All right. You learn about slope earlier on, okay? And they teach you how to find slope, y2 minus y1, and so on. That's the formula of slope, right? Slope, in actuality, right? Slope is the rate of change. So basically, if something is changing over time, let's say, right? Your speed is changing over time. Your distance is changing over time. Your grades are changing over time, okay? How quickly the change happens or how slowly the change happens is your slope, all right? So basically, it's the rate of change. Let's say you're driving and you have your foot on the gas pedal and you're increasing your speed, right? You were at 10 miles an hour and then 20 and then 40 and then 60 and then 65, right? And you can watch the speedometer. The speedometer could go up slowly or it could go up very quickly. The rate of that change is the slope. All right. Now, what we have here, yeah.
This is only for something with a constant rate.
No, anything can change.
I know, but with the speedometer example, I don't go from 1 to 60.
Right. It doesn't matter. So is the speed changing?
Yeah.
Yes. And then there could possibly be a way to calculate the rate of how that's changing. It might be linear, it might not be linear, but there is a possibility to calculate the rate of that change. Okay, here we have a function. We are starting with a basic function, x plus 2. F of x is equal to x plus 2, right? So that's y equals x plus 2, and you can see the graph right there. Now, suppose I wanted to find the slope of this linear curve at a specific point 3, 5, right? So 3, 5, that's that point right there. I wanted to find the slope at that point right there, okay? Now, one thing I could do is I could pick 2 points before and after, and so I can pick one point here, and I'll call this x1, and I'm going to pick another point there, and I'll call that x2, right? And I could find the slope between those points, and that would be, if y1 is here and y2 is here, it would be y2 minus y1 over x2 minus x1, right? Now, that's fine. So I can find the slope of the 2 points before and after, and that's the same slope as it's the same as the slope at that point. Is everybody okay with this? Okay. You can use that point, or you could use any 2 points, basically, right? Okay, so now, just a little bit of notation. It's fine to call the y values y1 and y2, but remember we also call y f of x. So this could also be f1 of x, or it could also be f of x1, right? And this could be f of x2 or f2 of x, all right? So now I can modify my formula from y2 minus y1 to f2 of x, or f of x2 minus f of x1 over x2 minus x1, okay? All right, so the moral of the story here was that if I wanted to find the slope at that point, I could pick 2 points away from the point, find the slope, and it would be the same value. Now, that's because that curve was linear. What if the curve is not linear? Okay, then that process is not very accurate. So suppose I wanted to find the slope of x squared at 1, 1, right? 1, 1, well, that's over here. All right, so one thing I could do, again, I'm going to pick 2 points and try to find the slope. Now, let me just zoom in here a little bit. I want to find the slope there. So if I were to draw the slope at that particular point, if I really wanted to zoom in and see what the slope was. That looks like it's the slope, right? Now let me just make that a little bit bigger. Do you see that? Now, let's see here. Look at that green line. At how many points does it touch the curve? 1. If something touches the curve at 1 point, what's it called? It's a tangent. So basically, finding the slope of at that point means find the slope of that tangent line. Okay? Now, so now I'm going to pick 2 points like I did above. And I'm going to connect those 2 points with that red line. At how many points does the red line cross the graph? 2. Is that a tangent line? No. What is that called when it touches it twice? It's called a secant line. Okay, it's called a secant line. So, do you notice how picking any random points is not accurate because it doesn't get me the slope of the tangent line? Okay, now what can I do? What if you say to yourself, oh my God, okay, so look. Here, I picked this point for x1 and this point for x2, right? So now you say to yourself, okay, what if I bring the points closer to each other? So what if this is x1, I make x2 here? Okay, what happens then? Look, does the line change? The line changes a little bit. Is it still the same as the tangent line? The tangent line was here. It's still not the same, but it's getting a little bit closer. So now you say to yourself, okay, you know what? I think I'm on the right track here. So if this is x1, I'm going to put x2 right next to it. Okay? Now take a look at that secant line. Is it closer to the tangent line? It sure is. It's almost perfectly matching the tangent line. Okay? So if I want to find slope then, I still can pick 2 points, but where do those 2 points have to be? Really, 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 really close to each other. Okay, so here, how far away are they? A distance of how much? From 1, it's a distance of 0.1, and even that's too far. I want to get that distance to be less than 0.1. Okay? I want that distance to be almost 0. Okay? So now, take a look then. As the 2 coordinate points move closer and closer, the secant line becomes a better approximation of the slope. Okay? And what we want, the most accurate approximation, is the tangent line. So what I want now is to devise a formula for the slope of the tangent line. Okay? All right. So, what is the slope of the secant line here? So look, if I pick 2 points, yeah. Okay, if I pick 2 points, then the slope is f of x2 minus f of x1 over x2 minus x1. That's the slope of the secant line, right? Now, how do I turn that into a tangent line? What do I have to do to the 2 points? Bring them what? Closer and closer and closer to each other. Okay, look. x1 and x2 are fine, but it's too many variables to keep track of, like too many subscripts. So here's what I'm going to do. Suppose this is x1. Can I call that distance h? Is that okay if I do that? Okay? Sure. Now, if that's x1 then, right, then where is the new coordinate? What's the other point? What's the coordinate of this point then here? If I start at x1 and I go over h units, where have I landed? x1 plus h. H is the distance between the 2 points. So if I start at x1, then the other one is x1 plus h. And you know what? Now that I don't have x1 and x2 anymore, can I just call it x? So x and x plus h, is everybody okay with that? Now, if this is an x value, then the y value is f of x, right? Say yes.
Yes.
Okay, now, if this point is x plus h, what is its y value? f of what? X plus h. Okay? So we're calling x1 x now, and its y value is f of x. Is everybody okay with that? And if this is the point x plus h, the y value is f of x plus h. Cool? So now, can we write that formula again, but using this new notation? So instead of f of x2, what do we have now? F of x plus h minus f of x over its h. Okay. H is the distance between the 2 points. Okay? This is x1, this is x2. The distance between them is h. Yes or no? Okay. Right. So to make this into a tangent, okay, I need to bring the points closer. Okay, if the points get closer, what happens to h, that distance between them? It gets smaller. So that means h gets smaller. How small? Almost 0. So h is going to approach 0. So check out what we're going to do now. We're going to do the limit as h approaches 0 of that. Okay? So now that, what is this? What have we found now? This is the slope of what? The slope of the tangent line at a point. Okay? So that's the slope of a tangent line at a given point. All right, so here it is. Slope of a curve at a point is just that, which we just came up with all on our own. Okay, it is pretty cool. Okay, so now check it out. Remember how you were saying like the change from 0 to 60 might not be linear? Here it is. This is a curve that is not linear. If I wanted to find the slope at this point, that's what the tangent looks like. Okay, so it's got a slope of like whatever. Okay, if I wanted to find the slope at this point, that's what the tangent looks like. Are those two lines the same? No. So is the slope at the first point the same as the slope at the second point? Heavens, no. If I wanted to find the slope here, look, it's negative. It's not the same at all. So if the curve is not linear, the slope at each point is different. So now what we want to do, we want to find the slope at 3, 9. Okay? So what we want to do first is we want to find the slope of the tangent line. This is equal to the limit of f of x plus h minus f of x over h. Oh, no, wait. Sorry, hang on. The limit as h approaches 0 of this. Okay, because we want the slope of the tangent line. Now, okay, stay with me on this, guys. What's f of x here? No, the equation. F of x is x squared, right? That's the equation that I'm given here. So now, just for funsies, what would f of a be? What would f of a be if I asked you f of a? Like a squared. Right? Okay, what would f of 3 be? 9. So now what would f of x plus h be? X plus h squared, which is x squared plus 2xh plus h squared. Okay, now, can I put that in there? F of x plus h is x squared plus 2xh minus plus h squared minus f of x, the formula says. What's f of x? X squared over h. So now what can we do? I can cancel out, so look, the x squares go away. So now I have 2xh plus h squared over h. This is equal to the limit as h approaches 0. I can take out an h from everywhere. 2x plus h, whoops, no denominator. So now, when I plug in h equals 0, what is this equal to? 2x. So, what this tells me is the expression for the slope of this tangent line, the slope is always changing, right? How is it changing? It's changing according to 2x. So now, how much is the slope at x equals 3, y equals 9? Let's see. At x equals 3, m is 2 times 3, 6. So at that point there, the slope is 6. Do you see what we just did? Come on, tell me. I mean, you can't tell me that's not cool. Okay? All right, we're going to do the same thing for this one. Okay? That's all. All right, we're going to do the same thing here. So let's find f of x plus h first. That's x plus h squared plus 4, x squared plus 2xh plus h squared plus 4. I'm just substituting. We're good with this? It's x squared plus 4. The function is x squared plus 4. So now I substitute x plus h here. X plus h squared plus 4. Huh? Okay, so how would I find f of a here? You just put a into x, right? So it would be a squared plus 4, right? So now how would I find f of x plus h? It would be x plus h squared plus 4. Yeah? Okay. So now, what's the slope here? The limit as h approaches 0, f of x plus h minus f of x all over h. So, what's f of x plus h? We just found it. Right? Okay, minus f of x. F of x is x squared plus 4. All over h. Okay, so now I'm going to do a little bit of, like simplifying and stuff. So look, what happens here? X squared minus x squared goes away. 4 minus 4 goes away. So I'm left with 2xh plus h squared over h. The h's go away. So this is the limit as h approaches 0, 2x plus h. And when I plug in h is 0, 2x. Okay, now, at x equals -2, m is equal to -4. All right? Now, if it tells you to find an equation at any point, right? At any point, you just leave it in terms of x. You just leave it in terms of x. Okay? Yeah. No. Okay, you just don't do that last part in the blue where you plug in a point value. You see what I mean? Okay, so let's do this one. So the first thing, you want to do some preliminary work. Find f of x plus h. So go ahead and do that like very quickly, like PrecalcHon style, quick.
This is PrecalcHon.
Yeah. It's algebra. It's algebra 1.
Is that a buffer below PrecalcHon?
Huh? Algebra 1. This is algebra 1, algebra 2, pre-calc. We're up there. We're up there. There is geometry somewhere in there. You did do geometry. He's trying to tell you they're smart.
Pre-calc.
He's
You're smart.
No, God no.
Well, you're in class with Noah's.
pre-calc is a little bit of a humbling experience. They've found.
What's harder, pre-calc or AP Euro?
Ooh.
It's harder?
Yeah, yeah.
Well, definitely for you.
Excluding the AP test. No, you can't exclude it. Even with the AP test. I study a lot more for AP Euro.
Oh.
Pre-calc is harder.
So what do we get here? Final answer. Whoa. X squared plus what?
X squared minus 2x minus 4.
Is that right?
What is H? What is H? I'm very confused on what H is. I can do this. Yeah, but like I get that, but like when it's an equation form, I don't know how to find that. Because with this, like okay, fx squared is just squaring that equation right there. But then plus h squared is where I get confused.
No, there is no plus h squared. It's f of x plus h.
What do you do? Is that? But that's not x plus h right there. What are you squaring when you do fx?
Oh wait, that wasn't supposed. This is what we need to find.
Sure.
F of x plus h. Okay. Algebra style. Okay, so now the slope is the limit as h approaches 0 of f of x plus h minus f of x over h. So now I'm color coding for you guys. This is the limit as h approaches 0 of f of x plus h is this. What do you mean? Okay. Hang on, let me finish this and I'll take you. So minus f of x is this. Okay, it's minus, so I'm gonna distribute the negative in one shot, okay? All over h. So now you need to cancel whatever goes away. A lot of things will go away. The 2 and the 2, the minus 4x and the plus 4x. So now you're left with 2xh plus h squared minus 4h over h. If this doesn't happen, if you don't get to a point where you can now get rid of the h's and get rid of that h in the denominator, then you've done something wrong, okay? Because the function is giving to you in x squared, 4x, and 2 in terms of x. Is there an h in the function? You yourself were the one who introduced the h. In math, when you introduce a brand new variable, in the end, it must go away again, okay? So, this is the limit as h approaches 0 of 2x plus h minus 4. Now we plug in h equals 0, and I get that the slope is 2x minus 4. That's all you have to do. Okay, now let's do one more. This is the slope at any point. This is just a general form. Okay, now let's do the same thing here. So first, you always have to find f of x plus h. And f of x plus h here is 2 over what? X plus h. And now you just plug it into the formula. So you have 2 over x plus h. So the slope is the limit as h approaches 0, f of x plus h minus f of x all over h. So this is the limit as h approaches 0, 2 over x plus h minus 2 over x over h. Now, I need to do some algebra. I need to find a common denominator. So look, h on the bottom just stays. In the numerator, what's the common denominator? X plus h. And what I have there is 2x minus 2 times x plus h. Yeah? F of x is the function that's given to you. Why? Okay. Now, this is the limit as h approaches 0. Just a little bit of simplifying. 2x minus 2h over x plus h. I'm taking my sweet little time here. So I get negative 2h over x plus h over h. Now that denominator, that h, is that like h over 1? Right? So now, if I have something in the numerator here and the same thing in the numerator here, can I get rid of them? I sure can. So now, we're getting back all of our algebra skills here. What's left in the bottom here? Just a 1. So what I have is negative 2 over x plus h. Now you can plug in your h equals 0 and you get negative 2 over x squared. So the slope is negative 2 over x squared. And that, ladies and gentlemen, is the equation of the slope at any point of 2 over x. Yeah. Velocity is average rate of change. Okay? Basically, it's the total change in distance divided by total time. If you drove 300 miles, right? And it took you 5 hours to get there, right? What's your average velocity? If you drove, suppose you drove, you went on a trip, and you drove 300 miles, and it took you 5 hours exactly. What was your average velocity? 60. What did you do? The total time, the total distance divided by the total time. So basically, if you are measuring distance like this, so suppose you started at 3 and you ended up at 23, okay? Meters. What's the total distance you have covered? 20. How did you do that? Your final distance minus your initial distance, right? So average velocity is your final distance, f of b, minus f of a. Now, in math, we use f and a and x and y. You may also see average velocity as, distance might be given to you in terms of s. So it could be s of t1 minus s of t2 all over t. Okay? So different notations for the same thing. So basically what I need here is I need the final point, the initial point, and the difference in x's. Okay? So for average velocity, you need final point, initial point. All right, so a water balloon is propelled straight up using a launcher. The height of the balloon in feet is given by this, so that's the height of the balloon. What was the balloon's average velocity between t equals 1 and 2 seconds? Okay, awesome. So what I need, I need d of 2 and I need d of 1. So d at 2 seconds is how much here? 5 plus 130 minus 16 times 4. So it's how much? So this is 71 and 54. So V average is equal to D of 2 minus D of 1 all over 2 minus 1. So that's just 71 minus 54 over 1. So V average is 17 feet per second for this one. Now, what is the sign here, SIGN sign of the answer that we got? It's positive, right? Is that significant? What does that mean? It's going in the positive direction. So in this case, where is it going? Up. Right? This is being launched straight up, so it's up. Okay, so we said that on this road trip of ours that was 300 miles long and that took 5 hours, we said that our average velocity was, about 60 miles an hour, right? Now, does that mean that at every single point in time, my speedometer showed 60? No. Sometimes I went up, sometimes I went down, right? Now, at any given moment, if the person sitting next to you said, hey, what does it say on your speedometer right now? And you looked and it said 64. What is that? That's not your average velocity. What is that? That's your instantaneous velocity. Instantaneous velocity is the velocity of an object at a specific point in time. That's all it is. At this time, how much was your velocity? Okay? In other words, okay, velocity is the rate of change of your position. Okay? What's another word for rate of change? Slope. So, if velocity is the slope of your position, instantaneous velocity is the slope at a specific point. So look, if this was the expression for your velocity, if this was the general expression for your velocity, when you plug in a specific point, then that's your instantaneous velocity. And that is amazing. This is the reason why Newton invented calculus, is so he was able to explain the laws of physics, acceleration and velocity and force. He needed a way to explain it mathematically. There wasn't a way. So he invented calculus so he could explain velocity and force. Okay. So instantaneous velocity then is the limit as h approaches 0 of f of t plus h minus f of t over h. F of x plus h minus f of x over h. Okay. This poor guy, window washer, drops his lunch off his scaffold.
I would cry.
So the scaffold is 1,400, okay, 1,400 feet above the ground. Shh. This is the position. Find the instantaneous velocity of the lunch at 7 seconds. So what do we need to do? Okay. Plug in 7 after we find the slope. Shh. Okay, so first of all, we need what? D of, okay, so t plus h. So first we need this. And now I'm going to spare you the algebra and just tell you that it's that. Now, V of t is equal to the limit as h approaches 0 of d of t plus h minus d of t over h. Okay, now we put in here, stay with me here because I'm going to combine a couple of steps. So we put in here what we just found. Okay, minus d of t, which is, so it's minus 1,400 plus 16t squared, right? Because we distribute the negative. Okay, now watch what I'm going to do. the negative, the negative 16t squared and the positive 16t squared go away. So do the 1400s. Now, in this same spot, it doesn't make sense to write it again. We're in pre-calc honors, for goodness sake. I'm just going to get rid of the h, the h, the h, right? Just to minimize negative 32t minus 16h. And if I plug it in, then v of t is what? Negative 32t. So that is the velocity, you know, over the entire time. But what I want now is the velocity at t equals what? 7 seconds. So what I want is v of 7. Okay? V of 7 is negative 32 times 7. So v of 7 is negative 224 feet per second. Oh my gosh. There you have it. That negative velocity means it's going in the negative direction.
Wait, so what about a car? A car doesn't go up or down, it goes sideways. It goes reverse. It's going backwards. So like if the car's going backwards, then it'd be negative?
Okay, so the distance in feet of a water rocket from the ground after t seconds is given by this. Find the instantaneous velocity, find the instantaneous expression for the instantaneous velocity at time t. Okay, what do we do here? We just have to find s of t plus h minus s of t over h as h approaches 0. Now, we all know how to do this. Do we then have to plug in a value once we get the answer in variable form? No. So that's where you stop. So let's move on to the next one. That one was an extra problem, and we all know how to do it. So we're going to move on to the next one. Okay. So here we go. You have a function given by 3x squared. It says find the average velocity. So now we have average velocity and instantaneous velocity. For average velocity, what is it that we have to do? F of b minus f of a over b minus a. That's the average velocity. Okay? So now, f of b is f of what number? 5, which is equal to 75. F of a is f of 1, which is equal to 3. So v average then is equal to 75 minus 3 over 5 minus 1, which is 4, 18. Now it says to find the instantaneous velocity. For the instantaneous velocity, I need the limit as h approaches 0 of f of t plus h minus f of t all over h. Okay? So now, f of t plus h here is 3 x plus h squared. And bear with me here as I just do that mentally. So, it's t plus h squared. So it's 3 times t plus h squared. So we're going to get t squared plus 2ht plus h squared times 3. So 3t squared plus 6th plus 3h squared minus what? 3t squared over h. The 3t squares will go away. I changed it to t instead of x. So this is, what is it? 60 plus 3h. So v is 6t. And V of 4 is 24. That's all. Okay? Now, for homework, we're going to go up to and including number 39. Not the last three. No, don't cross them off. You're going to do them for another day. Okay. Now, let me